So I'm going to run through practice problems for your exam. I think I already did one in class, but in case I didn't, I'll write it out. X squared minus x 46 over, and we already have a factor minus 1 plus. The form of this partial fraction decomposition a over x minus 1 plus x plus c over x squared plus 4. And that's because the denominator in the second fraction is reducible quadratic. So have an x term and a constant in the numerator. Anyway, what we have, we multiply both sides by the denominator. This gives us 15x squared minus x plus 46 equals a times x squared plus 4 plus x plus c times x minus 1. We let x equal negative 1. Then this gives us 15 plus 1 plus 46 on the left, and a times 5 right. Nice if that isn't. If this were a positive sign here, then it would be 15 minus 1 46 but equals. That'd be really. Okay. Well, but it's not. So we get a times 5. So a over 5. Okay. Then after that, actually, I'm going to call an audible on. I'm going to just positives. And the reason I'm doing that is because I think that having an example that has nicer numbers is helpful. Having an example that I'm going to change that to a negative sign. This plug in minus 1 60. I think that this will just make a clearer example problem than because then we can focus on the techniques of fraction decomposition rather than the fraction. Anyway, there we could plug in if we wanted to. We could x equals 2I. That would turn that factor into 0. I have a feeling like even though that would be probably, I think a lot complex. So I'm going to show you how to do it with no complex, and I'll go back and do it. Make a decision yourself. But if we're not plugging in any other values, then we have to multiply and group. So we get ax squared plus 4a plus bx squared c minus b. Taking all of these. After that, we will regroup, gathering our like terms together. A is 12. We already found. Plug that in. So we get 12 x squared plus x squared. Factor out, get x get minus c. What we know is that the left and right sides have to be everywhere, meaning that the x squared coefficient side has to equal. So if 15, 12 plus, that means that b equals. And here, if 48 minus c has to equal 6, that gives us c. Once we have all of those, we've now solved the problem. 12 over 1 plus was 3, 2. This 12 over x minus 1, 3x plus x squared plus. Find the determinant and the inverse of this 2 by 2 matrix. Determinant is going to be those multiplied together minus those multiplied. Get 2 minus 25 for the determinant. Three. Inverse function. For the inverse of this matrix, we have a formula for that. 1 over the determinant, found was -3, times, which top left and bottom right entries. We multiply the top right and bottom left entries. Formula. Where we A we are not having series on the test. That's going to be in November. Form this matrix arithmetic. We're going to clear this matrix. We have itself minus 8. I can distribute this sign. Of course, -0 is just that. Applying this, we're left and right. 0 is 0, 0. One plus 1, -4. -1 minus 4 is -5 plus 3. 0. Minus graph this nonlinear off vision of a circle of radius 5 at the origin. Find that by radius, and um, general form circle with the center at 8. But as you can see, we're subtracting nothing from x, nothing from y, which means 0, 0. 0 subtracted from x, 0 subtracted from y, 0, 5 circle. Okay, so there's our circle, and then we have this line. This line, if we plug in x is 0, y equals 5, is y-intercept. If we y equals 0, we get x. 2.5 is the point. And need to figure out where these. It's pretty obvious 5 is in it, but we need to find out where the coordinate at this point. The way we do it is we're going to plug this that one, solve this one. We get y equals 5. The other was 5. Solve for y as y equals 5. This we y squared equals 5.